companies like Facebook and Google are always looking for new applications for machine learning. Our Nick Heath caught up with the AI engineering chief for Facebook. And in your research, Nick, what did you find, or what did they report are the biggest obstacles when it comes to bringing in more of this machine learning?
So there's a couple of major obstacles. A big one is that it requires so much data to train these machine learning systems. They're basically learning by example. So you might think of a system that has millions and millions of photos with cats in them, which have been labeled to say this photo has a cat. But the problem is that to drive the accuracy rates up, you need more and more data. And as time goes on, they're needing more and more data, and the manpower required to label millions, and it's now got up to a billion scale, is just too much. So that is really one of the big problems, is that having enough manpower to label the data that these systems need. And then the other side of that is that there's also a need for a lot of computing power. So speaking to me, the Facebook AI platform chief was saying that just training one of these image recognition models requires an equivalent amount of computing power that if you gave every person in the City of London one operation to do, it would take them 4,000 years to complete, because it's one exaflop of compute. So you're getting to the scale of data, you're getting to the scale of computing power, which requires an entire data center.
All right, so that is a major task to even begin to process, Nick. So what about solutions, though? Did he talk about that, how they're going to face these challenges?
Yeah, so basically, they're trying to cut the humans out of the loop. So because it's the manual overhead which is the real problem. So they're looking at automated solutions. What Facebook have done is use hashtags associated with images on Instagram to label them. And doing that, they were able to create a labeled data set of 3.5 billion images. So this is what's driving them up to that huge scale of data that they really need to train these systems. And then from the hardware point of view, what you're finding is companies like Google are creating their own custom chips, which are designed to excel at the type of calculations that machine learning requires. So it's all of the customization is actually done at the silicon level, in the hardware. So, and examples of those, what are called application-specific integrated circuits, or ASICs, are Google's tensor processing units, which are starting to roll out across their cloud platforms.
Okay, and what did he mean, Nick? I know in your interview, he talked about machine learning's Moore's Law. What did he mean by that?
Well, Moore's Law was the observation made by Intel engineer Gordon Moore that the number of transistors on a chip would double every 2 years. And that's really what's driven a lot of the advances in computing over recent decades. It is starting to slow down now, but that's really been the engine of change in the computing industry. And what he was saying was progress in the field of artificial intelligence is going to require research breakthroughs. And this is why he referred to a Moore's Law, because he said that the number of research papers that are being written now that are citing this seminal paper in machine learning that was written by a researcher named Yan LeCun, the number of citations of that paper are just growing at an exponential rate. And he says that's basically reflecting this explosion in the rate of machine learning related research, which, will only lead to an increased chance of breakthroughs, because without the research being there, you've got no chance of the breakthroughs. But with there being so much research going on at the moment, he's saying that this is going to be the engine that's really going to drive forward progress in AI.
Wow, fascinating changes there, Nick. Thanks so much for talking here with us. For more, of course, on Nick's interview, just check out Tech Republic.